GraphQL, what is it? At its core, GraphQL is nothing more than a specification. It describes how clients and servers communicate to pass information back and forth. That's it. In that respect, GraphQL and REST are similar. They both define a commonly understood mechanism for, say, a user in a browser to request a particular bit of information from the server that supplies the data. Let's take a hypothetical example and see what this looks like. I'm a user that has browsed to the Definitive Superhero Information Repository website. I really want to know the list of names of all the superheroes that the site contains. The website has a button for just such a query. When I click it, a request message will be constructed that describes what I'm asking for. It could look something like this. Now, that's not quite enough information for a GraphQL request, however. In addition to the operation we want to invoke, in other words, here we want to execute the superheroes operation that will gather information about all the characters it knows about. We also need to supply what information we want returned. For example, let's say we want the name returned. So our complete, albeit simple, GraphQL request message could look something like this. So, a GraphQL request will consist of at least two parts. You specify the operation you want to perform, and you specify the shape of the information you want returned. In our example, we requested the superheroes operation that gathers all known characters. Then, we specified we only want the name field of each character found returned to us. Now, you might be wondering, how do we know what operations are available and also what fields are available for the response message? Perfect timing. Let's talk about that now. GraphQL is a strictly schema-based interface. There is no guessing about what operations a data server will expose, and there is no ambiguity about what fields an operation can return. Every operation that a GraphQL server accepts must be described in a schema. Likewise, the fields available to be returned from any given operation must also be completely described in a schema. So what does a schema look like? Well, they're nothing more than text files formatted in something called schema definition language. Really, it's very close to JSON documents, but not quite the same. Let's take a look. For our imaginary website, the schema might look like this. First, we see there's a single operation for query called superheroes. What follows is exactly what the operation will return. In this case, it's an array of objects of the character type, which actually makes sense. You can think of GraphQL types as object definitions, similar to Java class definitions, for example. Next, we see the character type definition. It has two fields that show both the field name and data type. You'll see one for name and one for age. The only thing that might be strange is the exclamation point after string. This just says that the field named name will contain string values, and the exclamation point says that every field that returns must contain an actual value. In other words, null values are not supported and not allowed for the name field. The second field, named age, will contain numeric values. Since there's no exclamation point here, values for ages are allowed to be missing or null. You'll often hear about data services supporting CRUD functionality. That stands for Create, Retrieve, Update, and Delete. Our GraphQL query operations satisfy the retrieve functionality of CRUD type operations. Before we wrap up this section then, let's see how we round out the rest of the CRUD functionality. There's a second main kind of request we can make. In GraphQL, we call them mutations. A mutation is any request that causes some kind of change in the data state on the server. These are also defined as operations and are also strictly schema-based. For our example of the earlier case, we could have a mutation operation called addSuperhero. We could pass in the information we want added, such as the new character name and age. For mutations, you're not limited to just adding either. We could also change an existing character in the system, as well as we could delete one. With mutations, we round out the typical CRUD operations for data management. There's one more kind of request that can be made to GraphQL servers. They're called subscriptions. We won't go into much detail here except to say that subscriptions allow a client to subscribe to a GraphQL server for specific conditions. When the condition is met, a message will be generated on the server side and sent to the client. It's more of a push model here. For example, it could be possible for a client to subscribe to our server and request a notification every time a new character is created in the system. This is a very powerful feature. Now, you probably won't see it nearly as much as you will queries and mutations, however. In summary, GraphQL is a specification that describes how clients and servers communicate. For a client to understand what it can do and to understand what it can request back, GraphQL relies on schemas to define both. The format schemas can take is defined in the schema definition language. GraphQL also supports all CRUD functionality. In the next section, we'll take a quick look at the history of GraphQL and how it came about and a little bit about why.